Unveiling the magic of metal casting, from sand to centrifugal. Hey everybody, I'm so excited to be talking to you today about a process that's absolutely fundamental to how we make things. Metal casting. Did you know that metal casting is one of the oldest manufacturing processes in the world? I mean, we're talking about techniques that have been around for thousands of years. From ancient artifacts to modern machinery, casting shapes our lives in ways you might not even realize. It's all around us. Today, let's dive into the fascinating world of metal casting methods and discover how they work. Chapter 1. Sand casting, the OG of metal shaping. We got to start with the OG, the one that's been around forever, sand casting. This method dates back to ancient civilizations, where it was used to create tools, weapons, and various artifacts. It's fascinating to think that a technique so old is still in use today, and not just in small workshops, but in large-scale industrial applications as well. It's like the granddaddy of all casting methods, and it's still incredibly relevant today. The process has evolved over the centuries, but the core principles remain the same. This longevity speaks volumes about its effectiveness and efficiency. So picture this, you've got a box, right? And it's filled with a mixture of sand and clay. This is our mold. The sand provides the structure, while the clay acts as a binder, holding everything together. This combination is crucial for creating a mold that can withstand the high temperatures of molten metal. Now we take a pattern, which is basically a replica of the object we want to create, and we press it into the sand mixture. This pattern can be made from various materials like wood, metal, or even plastic, depending on the complexity and size of the object. This creates a cavity, a negative space, in the exact shape of our desired object. The precision of this step is critical because any imperfections in the mold will be transferred to the final casting. We carefully remove the pattern and boom, we've got our mold ready for the molten metal. This step requires a steady hand and a keen eye to ensure the mold remains intact and free of defects. And let me tell you, there's something so mesmerizing about pouring that molten metal into the mold and watching it take shape. The metal flows into every nook and cranny, filling the cavity completely. It's like magic, but it's science. The transformation from liquid to solid is a sight to behold, and it happens relatively quickly, depending on the type of metal used. The metal cools and solidifies, taking on the intricate details of the mold. This cooling process can take anywhere from a few minutes to several hours, again depending on the metal and the size of the casting. Once it's cooled down, we break open the sand mold, and there it is, our metal casting. This moment is always exciting as you finally get to see the result of all your hard work. Sand casting is incredibly versatile. It's used in a wide range of industries, from automotive to aerospace, and even in art and sculpture. You can create large or small parts, simple or complex shapes, and it's relatively inexpensive, making it perfect for both prototyping and mass production. The adaptability and cost-effectiveness of sand casting ensure its place in the future of manufacturing. Chapter 2. Investment casting, where precision is king. Alright, now let's talk about investment casting, a process that's all about precision and intricate details. This method has been refined over centuries and is known for its ability to produce parts with exceptional accuracy and fine detail. It's a technique that's as much about art as it is about engineering. This method is perfect for creating complex shapes and achieving incredibly smooth surface finishes. Whether it's for industrial components or artistic sculptures, investment casting delivers results that are both functional and beautiful. Think jewelry, think aerospace components, think things that need to be perfect. The precision required in these fields is non-negotiable, and investment casting meets these demands with ease. Here's how it works. We start with a wax model of our desired object. This model is meticulously crafted to match the exact specifications of the final product. This wax model is then dipped repeatedly into a ceramic slurry, building up a ceramic shell around it. Each layer of ceramic is carefully applied to ensure the mold is strong enough to withstand the casting process. This shell becomes our mold. It's a perfect negative of the wax model, capturing every tiny detail and intricate pattern. Once the ceramic shell is nice and strong, we heat it up to melt out the wax, leaving behind a hollow cavity in the exact shape of our wax model. This step is crucial as it ensures that the final metal casting will be an exact replica of the original design. Now here's where it gets really cool. We pour molten metal into this ceramic shell, and it flows into every nook and cranny, capturing even the tiniest details. The metal fills the cavity completely, ensuring that the final product is both strong and precise. After the metal cools and solidifies, we carefully break away the ceramic shell, and what we're left with is a thing of beauty. The metal casting is then cleaned and finished to reveal its final form. Investment casting allows for incredible design freedom and produces parts with exceptional dimensional accuracy. This process is ideal for creating components that require high precision and intricate details. It's a testament to the marriage of art and engineering. The results are not just functional but also aesthetically pleasing, showcasing the skill and craftsmanship involved in this ancient yet ever-evolving process. Chapter 3. Now, if you're looking for speed and efficiency, look no further than die casting. This method is all about high-volume production, churning out identical metal parts with incredible speed. Imagine a steel mold, precisely machined to the exact shape of our desired part. This mold is made up of two halves that fit together perfectly. Molten metal is injected into this mold cavity under high pressure, filling every nook and cranny. The high pressure ensures that the metal fills even the smallest details of the mold, resulting in parts with excellent surface finish and dimensional accuracy. The metal cools rapidly within the mold, and once it's solidified, the mold halves are opened and the part is ejected. And just like that, you've got a finished part ready to go. Die casting is the go-to method for producing parts with thin walls, complex shapes, and smooth surfaces. Think about all the intricate components in your phone, your computer, your car. Many of them are made using die casting. It's fast, it's efficient, and it's everywhere. Chapter 4. Let's talk about continuous casting, a process that's revolutionized the way we produce large quantities of metal stock. This method has transformed the metal industry, making it more efficient and cost-effective. I'm talking about those long, continuous lengths of metal, bars, rods, slabs, you name it. These products are essential for various applications, from building skyscrapers to manufacturing everyday items. It's the backbone of industries like construction and manufacturing. Without continuous casting, the production of these vital materials would be slower and more expensive. Here's the basic idea. We have a bottomless mold, a reservoir of molten metal, and a system for continuously drawing out the solidified metal. This ingenious setup allows for a seamless flow of metal, ensuring that production never halts. Molten metal is poured into this mold, and as it comes into contact with the cooled mold walls, it begins to solidify from the outside in. This gradual solidification process is crucial for maintaining the integrity and quality of the metal. But here's the kicker. We're continuously pulling the solidified metal out of the bottom of the mold. This continuous extraction is what sets this process apart from traditional casting methods. It's like a metal waterfall that never stops. The flow is constant, creating an unbroken stream of solid metal. As we pull the solidified metal downward, more molten metal flows in from the top to replenish the mold. This ensures that the process can continue indefinitely as long as there is molten metal available. This process can go on for hours, even days, producing miles of continuous metal sections. The efficiency and scale of continuous casting are truly remarkable. Continuous casting is a game changer for efficiency. It reduces waste, lowers costs, and increases production speed, making it a preferred method in the industry. It eliminates the need for individual molds and allows us to produce vast quantities of metal stock with consistent quality. This consistency is vital for industries that rely on high-quality materials. It's a marvel of engineering. The precision and innovation involved in continuous casting are a testament to human ingenuity and the relentless pursuit of progress in the field of metallurgy. Chapter 5. Last but not least, let's talk about centrifugal casting, a method that uses centrifugal force to create hollow cylindrical parts with exceptional strength. Think pipes, tubes, rings, anything that needs to be strong and able to withstand high pressure. Here's how it works. We have a cylindrical mold that spins rapidly on a horizontal or vertical axis. Molten metal is poured into this spinning mold and centrifugal force does its thing. The outward force of the spinning motion pushes the molten metal against the inner walls of the mold, distributing it evenly and creating a hollow cavity in the center. The metal solidifies from the outside in as it spins, resulting in a dense, fine-grained structure with excellent mechanical properties. Centrifugal casting is all about strength and uniformity. The spinning action eliminates porosity and impurities, creating parts that can handle extreme pressure and stress. It's a testament to the power of physics and engineering ingenuity. So, whether it's sand investment, die continuous, or centrifugal casting, each method has its unique advantages and applications. From the ancient art of sand casting to the precision of investment casting, the speed of die casting, the efficiency of continuous casting, and the strength of centrifugal casting, these methods have shaped our world in countless ways. The next time you see a metal object, take a moment to appreciate the incredible process that brought it to life. Which casting method surprised you the most? Let me know in the comments below. And if you enjoyed this deep dive into the world of metal casting, be sure to share this video with someone who loves learning about manufacturing. Let's keep the conversation going.